So number 42, an object attached to a spring vibrates with simple harmonic motion as described by this graph. For the motion A, find the amplitude, B, the period, C, the angular frequency, D, the maximum speed, E, the maximum acceleration, and finally F, an equation for the position in terms of a sine function. Speaking of a sine function, please note that this is a sine function, starting out at 0 at t equals 0, and completing it looks like one oscillation every 4 seconds. Because it's already in the sine format, instead of using any kind of phase shift, let's go ahead and write its equation in terms of sine. So here's the equation. Notice that I changed our cosine to sine, just so it makes it easier to fit this graph. Doesn't affect anything. But then what's the amplitude going to be? Well, if you look at it, because it's centered on 0, this is actually a pretty easy one. It goes up to 2 centimeters and it goes down to negative 2 centimeters. Be careful, by the way, AP loves to throw in an offset where it doesn't start at 0. But take a look at your maximum and minimum, figure out the average of those two. In this case, our amplitude is plus and minus 2 centimeters, or 0.02 meters. Again, we always want to express our answers in meters. B, what's the period? Well, we already talked about that. It looks like it completes one complete oscillation in a total of 4 seconds. It comes back to 0 and then it repeats again at this point right here. C, the angular frequency. This one trips up a lot of people. Please remember, you can write angular frequency, omega, as 2 pi times the frequency. And so what they're looking for in this case is simply what is 2 pi f equal to? Well, we don't know the frequency, but we do know the period is 4 seconds from the previous answer. So you can very quickly just plug this in. Again, remember, frequency and period are reciprocals of each other. So the frequency becomes 1 over 4 seconds. And so if you solve that, you just simply get pi over 2 hertz. Yes, you could write that as a decimal, 3.14 divided by 2. But I'm going to leave it just in terms of pi, a little bit more precise in this case. D, the maximum speed. So for maximum speed, if you remember, the general format of the velocity equation is the same in a lot of ways, except cosine would become sine, or in this case, sine becomes cosine. And the 2 pi f t, or 2 pi f that was inside of this times t, moves out front. And you might say, okay, great, that's nice, but how in the world do I figure out what the maximum of this equation is? Well, take a look at the cosine function. The largest and smallest the cosine function could ever be would be either positive 1 or negative 1. That's it. It can't go beyond that value. And so in this case, we're trying to figure out, hey, what's the velocity when this whole term is equal to 1 in the box? Well, at that point, if the cosine function is equal to 1, our maximum velocity is just going to be equal to 2 pi f times a, just this part in front of the cosine function. And so we can quickly solve it. Let me erase all the garbage there, just so you can sort of see it again. We just need to know when the cosine function is a maximum. Plugging in our numbers, we know that 2 pi f is equal to pi over 2 from right up above here, and our amplitude is 0.02 from up above. Multiplying that out, you get 0.01 pi meters per second, or for those of you who want to actually think in decimals, it would be 0.0314 meters per second to 3 sig figs. For question E, what's the maximum acceleration? Again, we're going to do a very similar thing. If you remember, the general format for acceleration is, again, we take another 2 pi f out front, and it now becomes 4 pi squared f squared times amplitude times if it was cosine becomes sine, if it was sine becomes cosine, but this does become negative. Not that it matters. In this case, when is the acceleration the maximum? Well, when this is equal to either positive or -1. In this case, let's think about it in terms of when it's -1, so we can lose our negative sign up front. Maximum acceleration then is just going to be equal to 4 pi squared f squared times the amplitude. We know that 2 pi f is equal to pi over 2. Well, 4 pi squared f squared is just that squared. So I'm just going to use pi over 2. The amplitude stays at 0.02, and our acceleration becomes 0.005 pi squared meters per second squared. Or in terms of a decimal, you could write it this way. That's just plugging in pi value. And then finally f, an equation for the position in terms of the sine function. Well, we've already done all the work. We know the general form is this. All we have to do is plug in our acceleration and what 2 pi f is equal to. In this case, it just becomes 0.02 times the sine of pi over 2 times t. I hope that this helps.